Now, when we're sizing valves, we're going to have, the rep is going to ask us a couple of questions. He's going to ask us what the flow is. Now, that's easy enough to find out. We just go and ask the operations people. This is for a system that doesn't exist. The other thing he's going to ask us is, what is the pressure drop across the valve? Well, I don't know. So there's a couple of ways of working out what the pressure drop will be. The first way, which I haven't even listed up here, is by looking at every single piece of pipe and every single elbow and every single bend and calculating the pressure drop in that particular item and adding them all together. Now, that's a horrific job and takes forever. The second system, if you can possibly do it, is to build the system and start the pump and see what the pressure drop is. Easy, really, just measure it. The third way is to find a big resistor, the biggest resistor in the system. Say, for instance, you've got a boiler, and you've got a pipe going into it and a pipe going out, and you need to put a valve there to control the flow into the boiler. Well, the valve has to be the same resistance as the rest of the system put together to give us an authority of about 0.5, yeah? What's easiest to do is just walk up to the boiler and look on the side of the boiler, because on the side of the boiler there'll be a little metal plate with things like boiler made by boiler manufacturers, whoever, and on that little metal plate will be pressure drop 400 kPa. So there you go. Now, I just use that for valve sizing, because although there will be a little bit more pressure drop in the rest of the system, the entire system pressure drop will be something like 406 kPa, because the boiler's the biggest resistor by far. So if you just walk up to the boiler, read off the metal plate that says 400 kPa, then we say, okay, we're dropping 400 kPa across the boiler, we need to drop 400 kPa across the valve. Easy, easy. Or if in any doubt, just get the rep to do it. Now, I've got some questions about valves in general. Okay, let's do the first question. What would occur if you failed to use, going all the way back to valves, what would occur if you failed to use a balancing valve when using a diverting valve on a heat exchanger? I think you're all hitting along the right lines. The boiler is going to get very, very upset. The boiler is going to overheat, it's going to overpressurize, and then it's going to short cycle. The boiler will start short cycling because it's going to try to protect itself. Okay, second question. Optimum range of valve authority. The optimum range. Remember, we never want to go too small. So what's the optimum range? Yep. The optimum range is between 0.2 and 0.5. Because when we go with authority, it goes 0, 0.5, 1.0. So this is going too big. This is going too small. No matter what, we never want to go too small. So 0.5 is our definite cutoff point. We only ever go too big. Point 2 is stretching a friendship. Definitely is stretching a friendship, but, you know, that's what we'll go to if we must. Okay, third question. Calculate the valve authority if delta PV is 15 and the system pressure drop is 60. Okay, so I've got 15 over 60. The valve authority is 0.25. The valve is slightly big, not overly too big. It's a bit big, but it's a fine valve. We'll use that valve. Okay, question 4. Water flowing through a fully open valve at a rate of 5 cubic meters per hour creates a delta PV of 0.25. What is the kV? So I need you to substitute 5 and 0.25 into the equation and tell me what the kV is. By the way, you don't even need a calculator for this. Thank you, Matt. The kV is 10. Oh, now I went a bit further, didn't it? Okay, so if my kV equals 10, but I need to buy an American valve, and the American valve is quoted as CVs. So I need to buy an American valve which is CV. So I need to take my kV of 10 and convert it into an American CV of something. If the kV is 10, the conversion factor is over here. If the kV is 10, what is the CV? Have another look at that, Matt. Oh, I see what you mean. Yes, you're right. The answer is 16. Yes, the answer is 16 because the CV is 11. Oh, let me go. The CV is 11.6. So yes, the valve we will buy will be the 16. Now, did it make any difference whether we worked in kV or whether we worked in CV? Which valve were we going to buy? Did it make a difference to the valve? The fact of the matter is, there are huge jumps between valve sizes. They don't make a valve which is 11.6, so we have to go to the 16. There are huge jumps between valve sizes, which is why it's okay to be really, really whooshy and, you know, wishy-washy with our calculations, because we don't have to be too exact. Even if we were silly with our calculations and we made it 14.7, we were still going to buy the 16. Okay. Next question is a difficult question. And I might work through that one all together. And the next question is, if the original valve in Q4 had an authority of 0.5, what would be the authority of the new valve? Okay, I'm going to work through that with us. So the original valve, I'm going to have to go back and look at that. The original valve had an authority of 0.5. So if the original valve had an authority of 0.5, 0.25 of a bar was dropped across the valve. That means 0.5, if it had an authority of 0.5, half of the entire system pressure was dropped across the valve. 0.25 was dropped across the valve. That means that the system pressure must have been twice 0.25. So the system drop would have been 0.5. So if the system drop was 0.5, and we have the equation, rearranging the equation for kV, which is what I've done just here. I rearranged the equation for kV. Rearranging the equation for kV, delta PV over specific gravity is 1, is Q divided by kV. So we've got that delta PV equals Q, and Q is still going to be 5 over kV. Now the kV of our new valve is 16 squared. So it's delta PV is 5 over 16. I'll give myself a new sheet here. Delta PV equals 5 over 16 squared. So could somebody just tell me what delta PV is? I also have delta PS equals 5. So if somebody could just work out, right. So delta PV equals 0.09. Right, so if delta PV is 0.09 and delta PS, the entire system pressure drop, is 0.5, then the new authority is the drop across the valve divided by the drop across the system. Delta PV divided by delta PS. So somebody tell me what the new authority is. .18, about 0.2. So the valve is too big. We know the valve is too big because we had to go, instead of buying the 10, we bought the 16. So the valve's too big. It's just about livable with. Just about livable with. In fact, we've really got no choice. So last question then. In simple terms, describe the characteristics of a valve. So in simple terms, authority 0.2. How would you describe that valve? Too big. Last one. In simple terms, authority 0.8. The valve is, by a process of elimination, the valve is too small. Remember, given the choice of going too big or too small, we always go too big. We don't go silly. If you go massively too big, you're going to get cavitation and flashing.